Hi, everybody. We are on our last lesson of the chapter, parts of similar triangles. Just heads up, it is conference night, so I'm sneaking this video in, hopefully before anyone else decides to conference with me. I think we'll be able to do it in one video, but just in case, there might be a part two. So suspense for everybody, me included. Okay, so like I said, um, last lesson of the chapter. Again, I know you're probably sick of me saying it, but we're gonna play the matching game again today. So today we're gonna kind of review from when we were doing distance learning, like an altitude, angle bisector, and a median. And when we have those in similar triangles, there's special relationships that exist. And basically, why is it important to us? Well, we can use those special relationships to find side lengths. So it's kind of like the same thing we've been doing with just a little new information. But again, all you're doing today is matching. So don't make it more complicated than that, okay? So, sorry for the long intro. I don't know, adrenaline, I suppose. Okay, so this should be first part of your notes here. Okay, so parts of similar triangles. So, like I said, it's been a while since we talked about these things, and we also talked about it during distance learning. So, I can't promise that I was the best teacher during that time for you or to you. So, let's hope that this is as painless as possible. But if we read here, it says if two triangles are similar, then the following corresponding parts are also proportional to their corresponding sides. Okay, so if we look here at this picture, if a line goes from the vertex to the opposite side and makes a right angle, hopefully you're thinking that's an altitude, because that's what it is, or we call it like the height of your triangle. So your altitude. So when this happens in similar triangles, now we just match. We can write proportions to find, let's say we were looking for a missing side of one of those triangles. So all you do is you match. So you put your altitudes over each other. So BD would match FH, because those are altitudes, right? They're in matching spots. And now you just kind of pick. Let's go AB. AB, what would that match on our smaller triangle? That would match EF. And that's that. Again, I always say this is a lot of words, not a lot of numbers, not a lot of math. It will make more sense when we see a problem like this. But just know if you have two altitudes in similar triangles, we can write proportions to help us solve for missing lengths. Okay? Okay, what do we call a segment that goes from the vertex to some random point but cuts this angle in half? That would be your key thing. It's cutting the angle in half. Hopefully you're thinking angle bisector. Yes. If you got that, good job. If you didn't, still good job. Still proud of you. Angle bisector. So again, we're going to play the matching game. This angle bisector, QS, over this angle bisector, UW. Go back to the triangle we started with. Pick whatever side you want. I'm going to do QR. What matches QR? Well, that would be UV. Now you're done. And then our last one here goes from the vertex to the midpoint of the opposite side. Well, how do I know it's the midpoint? Remember, those tick marks are telling us this distance is the same as that distance, so it's in the middle of that side. If you're thinking, starts with an M, rhymes with median, it is the median. The median, yes. So again, we're going to play the matching game. This median, JH, or HJ, over this median, LN, is equal to, pick sides that you want. I'm going to say GH, what matches GH, KL. Okay, so again, this is like our generic form that would work in any triangle. Let's try it now in some actual examples, okay? So we are looking for the value of X here. Just for good practice, let's just practice naming what kind of special segment we have happening here. So these special segments would be medians, right? It's going from a vertex to the midpoint of the opposite side. Do you guys see that? Tick marks. That'd be the midpoint. So that's just an example of a median. I'm going to write it. You do you. You don't have to, but I just like to know these things. And now, kids, we play the matching game. Okay, so if I pick my median on this triangle, it'd be x. What does x match in the other triangle? It matches 15. And now it's kind of your choice. You do you. I, for whatever reason, always kind of gravitate to the smaller numbers. So I'm going to pick 16. ST, what does ST match? ST would match 20. Again, you can use your code up here if that helps you. ST right here. First two would match DE, which is also 20. There's multiple ways you can do this. Just giving you some options here. And now you do the thing that we've been doing all chapter long, which is cross multiplying. So 20 times x is 20x. 15 times 6 is 240. Divide out x equals 12. That's it. Okay, let's do another one. So this time we are working with altitudes, right? It goes from a vertex and makes a right angle with the opposite side. And this one's not even all that tough, right? They're not giving us any extra information. We only have 4 sides with something that we know something about. So if we start, I put my altitudes over each other. So 10 over 8, come back to the triangle you started with, x over 14. And now we cross multiply. 8x equals 140. Divide out x equals 17.5. Are we okay with that? I hope so. If not, ask me in class. Okay, another one here. What kind of segment do we have happening here? It's cutting these two angles in half, right? So those would be our angle bisectors, or an angle bisector. And again, we're going to play the matching game. This angle bisector 32 over this angle bisector 24 is equal to, come back to the triangle you started with, 38 over x. Cross multiply. So we have 32x, 24 times 38 is 912. And then we divide out, kids. X should be 28.5. All right, and our last one of this type of example here, it's kind of tricky. So we're coming from a vertex of our triangle, and it's making a right angle, but it's not happening on the inside. So we didn't have an example like that. Just remember your altitudes can fall outside your triangle if they're obtuse, which these two triangles would be. So this is an example of an altitude. And now it's the same old song and dance, kids. Let's label our altitudes over each other. So I'm going to have 12 over 15 is equal to, come back to the triangle you started with, so x. And then what does x match? It matches 42. And again, if you're wondering how am I knowing this, look at your code up here. PQ matches UT, right? That's how you can verify what goes with what. Now we'll cross multiply. We'll get 15x. 12 times 42 is 504. Divide out, x equals 33.6. Oops, you can't see that. My big head's in the way. Sorry. 33.6. Okay. One more. We have a thing called the triangle angle bisector theorem. Again, a lot of words, but let's just read this together. An angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the two other sides. So instead of having two different triangles being similar and writing a proportion about them, this is happening in one triangle. So we only have one triangle here. This is an angle bisector, right? Because I'm cutting this angle up here in half. And when this happens, it creates a proportion between the two sides and then how we split the side that it connects. Bear with me. So what we can write is this chunk here, AD, so AD over DC, because that's the part it would match, is equal to, come back to the side of the triangle you started with. So since I started on the left side, I'm going to come back to the left side. So AB over the other whole side, BC. That is an ugly B. So just to kind of reiterate what happened there, when you have an angle bisector in a triangle, it splits the triangle into proportional parts. The side that you split is proportional to the two whole sides that nothing happened to. So that's why we were able to put the two parts over each other and set it equal to the two whole sides that nothing happened to. Okay? So let's finish up with two examples like this. So really the instruction should say that this is an KM is an angle bisector. Sorry that it doesn't. That's poor planning on my part. But okay, so if we write this out, I'm going to write 4.8 because that's my part of a side over the other part of the side, which is x, is equal to, come back to the left side because that's where I started, is on this left side of this triangle. So 12 over the other whole side of 18. And now we cross multiply. So we'll have 12x, 4.8 times 18 is 86.4. Divide out, x should be 7.2. All right, one more, kids. Kind of a goofy one. So again, this should tell us this is an angle bisector. So when that happens, our two parts of the whole side are proportional. So I can write 12 over, but now how do I represent this amount? The whole thing is x, and up to here is 12. What's left over of our x would be x minus 12 is equal to, come back to the side of the triangle you started with, so 18 over the other whole side, which is 30. And now we cross multiply. Okay, 12 times 30 is 360. And now we have to distribute that 18 to both the x and the negative 12. So I'm going to rewrite this quick. So we'll have 18x minus 216. Add over that 216, so we'll get 576 is equal to 18x. Divide out, and x equals 32. Okay. All right. Well, what's exciting is we're done with this chapter. What's also exciting is we were able to do this video in one clean swoop. So I think no matter what, it's a win. No matter if we're lost or not, I think we tally this up as a win for the day. Again, as always, thanks for watching. I will see you when I see you. Have a super rest of your day, and I'll see you in class. Bye.